So remember, the accounting for derivatives is fair value, and changes in fair value have to go through the income statement. So how do you value an interest rate swap? How do you determine the fair value of an interest rate swap? Well, subsequent to the financial crisis, they set up a loose market for valuing six basic types, or at least having a clearinghouse for six basic types of swaps. So there are market measures that exist out there to value certain types of plain vanilla swaps. And we're really only going to be dealing in this class with plain vanilla swaps. As they get more complicated, you at least have the building blocks of how to think about more complex swap arrangements. But for the basic interest rate swap, fixed to floating, there is a market out there. So we could always take a market approach. Now, these are not going to be identical contracts traded in an active market. So they're going to always be level 2 if you use that type of market approach. Because the data will be observable by market participants, but it's not an identical asset, right? Because most interest rate swaps are between two individual counterparties, and you have to factor in who has the credit risk. And whoever has the credit risk, then we have to build that in to come up with a fair value. So we're going to focus our attention mostly on thinking about this from an income approach to determine fair value. So we're going to look at it on an income approach. And again, we're going to do this pretty simply. Later on, I'll show you there's a tool that I created that you can use to value plain vanilla interest rate swaps. So let's assume for a moment that we have a fixed to floating, and it doesn't matter which side of the contract you're on. But let's say we are at, it's a 10-year swap. And the counterparties agree that we're going to swap a fixed to floating. And so they're going to swap the 10-year treasury for a fixed rate. So this is the variable leg. So this is our variable. And we're going to swap that for a fixed rate of, let's say, I'm just putting a number out there, 1.50%. Now, this right now, if you looked at this, the 10-year treasury, based on today's data, as of August 20th, 2020, is trading right now at a yield to maturity of less than 1%. But the person that's getting into this swap is probably believing that interest rates will increase in the future. And that's probably a good bet, but it's a bet. But they feel comfortable with this, the person that's getting out of the variable. So they would much rather, so in this particular case, maybe they want just pay the fixed rate, and they want to collect the variable rate, right? So this is the swap transaction they've gotten into. We'll talk a little bit later on about why somebody's doing this. What's the risk that they're taking on? Right now, we're just talking about what's the fair value of this thing. So what we want to do is we want to set it up, and we're going to assume that this is pay annually. That's pay, receive, or receive, pay annually. And we'll assume that it is the basis is simple at 3360 and the notional is 10 million. Okay? And we just got all of this from the contract, right? All those variables, we just pulled this from the contract. So, what we want to do is we want to set this up. We got all of our different years. We start here at 0, go to 10. Here's 5, 7, the 1, and the 2. Okay? And we're looking at what we believe is the forward curve at this moment in time. Right now, our fixed rate is 1.50%. What we want to do is, here are all of our years, right? We want to do 3, and then 4, 6, 8, and then 9, okay? So at each of these periods, there is going to be a payment. Whatever the difference between the fixed rate here, right, which is going to be consistent all the way across, versus our floating rate, right? And so what we do is we take a look at the floating rate. Let's say the floating rate right now, and we're just making some stuff up, is sitting at 1.40%. That's high for today's market, but we're just going to use this as an illustration. So it's sitting here. Okay? So right now, this is the forward yield, this is the forward yield. This is what we believe the 10-year interest rate is going to be, is 1.4%. So in year 10, we are estimating that we're going to end up having this be the difference, 0.1% times $10 million. We can go in and take a look at where we think the 1-year bill is. And the 1-year bill may be down here somewhere. And the 2-year might be a little bit higher. The 5-year might be around here. The 7-year here. Okay? So what we've done here is, just by looking at this little bit of a curve, we're going to just connect these dots. This is what we refer to as the forward interest rate curve, right? This is just what the market is now predicting of what rates are going to be at each of these discrete points. What we'll do is we'll take a look at the difference in each year. And this is, if we are the one who are collecting a dollar, 1.4% on the 10-year, we would theoretically, at each one of these points, we would be thinking that this is what the 10-year curve is going to be looking like. And so our difference here, our differential, would suggest that we're going to have to pay a lot of money here, less, etc. But overall, if we are the one who are receiving 1.4 and we're paying 1.5, then we're going to be in a loss position, because we're paying out more money at 1.5% than we're collecting at 1.4%. So the stream of these differential cash flows, we're going to take the stream and we're going to determine what's the present value of that stream of differential cash flows using the discount rate. And the discount rate we want to use is, since if we are the one who are paying 150 and collecting 140, then we have a liability. We have an accumulated liability for this particular transaction. So the discount rate we want to use, or the credit spread that we want to use, is our credit spread. Because the market is going to look to see, well, what's the probability that we as an organization are actually going to make these payments. So we look at this forward curve. Now, as this curve increases, so remember, we got into this thinking that interest rates are going to go up. Well, what happens if interest rates do start going up? Then it's going to tighten this curve. We'll put this in blue. So this is now a new curve. We're doing a new valuation. And now interest rates did go up. The expected interest rates have gone up. In this particular case, I'm going to be receiving more money here because I'm paying 150, receiving whatever the variable is. I'm still paying money here, but now when I present value this, the fair value, which was in a loss position with this first scenario, should now still be in a little bit of a loss position, but less of a loss position. And so just because interest rates went up here, I've made a little bit of money. So we have to get market data to figure out what is the change, and then determine whether or not that interest rate curve is in excess at any point in time than my fixed rate, and then get a present value of all of these differential cash flows between the fixed and the floating, and then present value that using a discount rate. And if I'm in a liability position, I should be using my credit spread or the company's credit spread, versus if we're in a receivable position for this. So say we're making money, or we should be receiving more money from the other counterparty. In that case, if this becomes a net positive gain, we should be using the other counterparty's credit spread when determining the discount rate.